So naturally or natural condensation polymers. The first one is the formation of a protein. So protein is actually a polymer, but how it is formed? Formation of a protein when amino acids, the monomers, mix with another amino acid. What it will result in a formation of a polymer which we call protein plus, because it is a natural, so amino acid plus amino acids give protein and water. By nature, naturally it can happen. But opposite is also possible, that protein can be hydrolyzed. The forward reaction is known as polymerization, where the reverse reaction is known as hydrolysis. When we use water molecule to decompose something, we call that as hydrolysis. So we are using water to decompose protein. So when amino acids mix with another amino acid form protein and water, protein is a polymer and which is formed by condensation. What are the structure of amino acids? From the name you can understand its structure. It is amine and acid. So basically it contain amine group as well as it contain acid group. So when we draw the structure of amino acid, this is one amino acid. This is one side it contain amine, another side it contain acid. And between them there is a carbon chain link. So we can use a box to show that symbolic representation. And another amino acid, this is amino acid. And there is another amino acid. And amino acid, as in bio you are studying, there are different types of amino acids. So they may be identical amino acid or maybe different amino acid. If they're identical amino acid, I will use the same symbol for both. If they are different amino acids, just I will shade the region to show they are different amino acids. So both are amino acids. So when amino acid mix with another amino acid, this will result in a formation of a protein. So how this protein is formed? One side amine will lose its H, carboxylic will lose its OH. Amine will lose its H, carboxylic will lose its OH. So what it result? If I remove H and OH, what is the result is a protein. So there will be N, H, then this box is there, then C double bonded with O, N, H, then there is a box C double bonded with O, and put N. And how many water molecules? If two molecules of amino acid, then it will give two water molecules. But if N molecules of amino acid 1 and 2, then it will give 2N H2O. And opposite is valid as well. Amino acid, this hydrolysis of the protein can form these amino acid. Is it clear? The formation of protein, how protein is formed when the small molecules join to form a long chain compound. Any doubt in this? This is a structure of a protein. And what type of linkage is there? This is protein. And what kind of linkage is there? What kind of bond you see? The same bond you see in nylon. So that is called amide or peptide linkage. So nylon, and so you will find amide or peptide linkage. The other polymer which is formed by condensation, natural condensation polymer, that is carbohydrate. The carbohydrate, what are the monomers? The simple sugar, the sugar molecules, the simple sugar or glucose molecule, these are the monomers. Or glucose as well, that's right. So when simple sugar molecules or glucose molecule will link with each other, what it result? It will result in a formation of a long chain compound which we call carbohydrate, and also release water molecule. So sugar molecules can join to form a long chain compound carbohydrate, or carbohydrate molecule dehydrolyze or hydrolysis, and the forward reaction, is known as polymerization. The backward is known as hydrolysis, when this carbohydrate molecule break down. Actually, what are sugar molecules? The simple idea that these are diols. The term diol means two OH groups are there. So how to draw a structure of carbohydrate? So you have H, OH, OH and H. That is one molecule. Then you have the identical glucose molecule. So how they will form a polymer? These are the glucose simple sugar molecules or glucose molecule, C6H12O6. Actually, they are diols. The term diol means they have two OH groups at the end. So how to form a polymer? So how to form a polymer? One side it will lose its H, the other side OH. One side it will lose its H, the other side OH, and just link them together to form a long chain compound. So there is O, that is oxygen. The first, because H is being removed, so the first one is oxygen O. Then there is a box. Then this OH and H being removed, so O. Then there is a box, and then put N, like continuation. plus 2NH2, and this is actually carbohydrate, which is having oxy linkage. Is it clear, the formation of carbohydrates? And the last one, the condensation polymer, is the formation of the fat. For this one, you don't have to learn the full structure of the fat because it's a complex structure. I will explain how it is formed, but in exam point of view, you just have to know the word equation rather than the structure of the fat. But I will explain how it is formed. The word equation, how fat is formed: when glycerol, the glycerol which is triol, tri means 3. So glycerol reacted with fatty acids, this will result in a formation of fats. So when glycerol reacted with fatty acid, it will result in a formation of a molecule of fat and water molecules. You have to learn the word equation, you should know. And the forward reaction is known as polymerization, where the reverse reaction is known as hydrolysis. That is why, like example, you will find if someone want to lose weight or reduce the fat in the body, they say drink lot of water. What is the reason, the chemistry behind that? Because when you are drinking lot of water, so the water molecule helps to hydrolyze this fat and break down into smaller molecules. So forward reaction is polymerization, reverse reaction is known as hydrolysis. So when glycerol, which is triol, is reacting with fatty acid, result in a formation of fat plus water. You don't have to learn the equation which I will write now. Just the word equation is important. So what is the structure of the triol? Triol means 3 OH groups are there. And they are linked with the carbon chain. This is a structure of triol. And what are fatty acid? Fatty acid means carboxylic acid with long chain compounds, with long chain carbon atoms. If you have 3 molecules of fatty acid, this is one molecule. This is another molecule. And this is a third molecule. And the box means like there are carbon atoms, but we don't bother about how many are there because that will not make a difference to the reaction. How they react with each other: if carboxylic loses its H, alcohol will lose its OH. If alcohol loses its H for reaction, carboxylic will lose its OH. So one side H and another side OH must be removed to form this product. So what will be the result? The structure, it will be a structure of the fat molecule. Like if I write this is CH2, so if this is CH2, H and OH are removed, so then it will be O, C double bonded with O, and this box means carbon chain. Then next to this CH2 down is CH, and after CH there is O, and OH, H and OH being removed, so it will be C double bonded with O and a box. Then down this CH, there is CH2, so CH2. Next to that is OH and H being removed, so we are left with this oxygen and C double bonded with O and a box. Plus, how many water molecules are there? This time it will give 3 water molecules. And what is this linkage in the fat? What kind of linkage is there in the fat? What kind of linkage you see in the fat molecule? C double bonded with O and O. What we call this linkage or a bond. So we call that as a ester linkage. So in a fat, you will find ester linkage. So when glycerol, this one is glycerol, react with fatty acids, this will result in a formation of a fat plus water. And the linkage which is there, the bond which is there, it's known as ester linkage, or which we find in ester C double bonded with O and O. One more thing which you have to learn, that if you have glycerol plus fatty acid, this will give fat plus water. This is called polymerization. Then hydrolysis of the fat. If we hydrolyze the fat, the equation will be fat plus water give glycerol plus fatty acid. But if we carry out hydrolysis in alkaline medium such as sodium hydroxide, so if we have sodium hydroxide and we are hydrolyzing the fat, it will produce fatty acid. So what will happen? The fatty acid which is produced by hydrolysis of the fat react with sodium hydroxide to produce a compound which we called soap. So manufacturing of the soap which we are using, that is manufactured by hydrolysis of the fat. They are using different types of fats. Animal fat can also be used for this production of the soap. Different types of fats can be used for the production of the soap. So basically what happened, the fatty acid, which is carboxylic acid, react with sodium hydroxide. Sodium hydroxide is an alkali. So fatty acid plus sodium hydroxide, what it result? It will result, this is like an acid-base reaction, so it's a neutralization. So it will give salt plus water. But basically, what is this salt? This salt which is produced, that salt is a soap. It is Different from normal salt because normal salt contain inorganic substances, but normal soaps, the salts of soap which contain organic and inorganic, both parts are there. Is it clear? The hydrolysis of the fats which result in a formation of fatty acid and glycerol. And fatty acid, if we do hydrolysis in the presence of sodium hydroxide, it will result in a formation of soap. So soap formation is by the hydrolysis of the fats. Any doubt in this? Now some questions I want everyone to answer, not now, as a homework related to this part. You can use your book or you can use internet as well to search for these answers. Write one similarity or two similarities and one difference between, or make it two, so you will, normally in exam they ask for one, but if you have two then it will be good, between nylon and protein, how they are similar and how they are different, between polyester, which is styrene, and fat, then write one advantage and one disadvantage of burning the polymers. If you burn polymer, what is the advantage, what is the disadvantage? Yeah, this is a homework. Recycling the polymer, or plastic, you can also say plastic. What are advantages and what are disadvantages? And using landfill, like to dispose of the garbage, we use a region and just dump the garbage on the land, that's called a landfill. So what are the advantages of the landfill and what are the disadvantages? And one more thing, right, difference between biodegradable and non-biodegradable polymers. And the difference between addition and condensation polymerization. This is a homework. So you once you are done, just send these answers after answering these questions. Now we'll do some questions related to the polymerization, the topic which we discussed today. So that is the last part of organic chemistry. In this organic chemistry, you have to learn about alkanes, alkenes, alcohol, carboxylic acid, and then the polymerization, addition, and condensation polymerization. Give two properties and uses of nylon and polyester. Now some questions related to the polymers, polymerization. There are two types of polymerization, addition and condensation. Explain the difference between the two types of polymerization. So what is the difference between addition and condensation polymerization? In addition polymerization, there is only one product is formed. But when condensation polymerization, it will form a polymer and water. Some plastic formed by polymerization are non-biodegradable. Non-biodegradable here refers to that the plastic does not decompose by itself. It will take longer time to decompose, like does or very long time or does not even decompose completely. Describe two pollution problem that are caused by non-biodegradable plastic. So what are the problem caused by non-biodegradable plastics? Yeah, water pollution, land pollution. Yeah, that's right. So you can mention animals can be caught in a plastic, like example, a fishing line, or you can mention a combustion of these can give a toxic gases, and it will use lot of space, landfill resources. Now in this question, polymer which is known as PVA is used in paint and adhesives. It is a structure form. Its structural formula is shown. Deduce a monomer. This is related to both addition and condensation both. So how to deduce the monomer or how to work out the monomer? What you will do, just take the two carbon atoms of the structure or out of the structure. So the two carbon atoms will take and hide rest of them. So if I hide rest of them and only take two carbon atoms from the structure, so what I'm left with, that is a monomer. So what I'm left with, CH2, CH, there is OCOCH3. And what we will do, we will just make a double bond. How we know this was addition polymer? Because in addition polymer, the polymer is formed by link between the carbon atoms. Like you will always find that all the molecules are linked by carbon-carbon bond. So you can work out it is addition. If the other atoms are also involved, such as nitrogen, hydrogen, or oxygen, it means that is condensation polymer. Is it clear how we deduce the structural formula of the monomer? Monomer means a small molecule. Polymer means long chain compound. So here they give you a polymer, like this is a polymer. You have to deduce a monomer. So how to deduce a monomer? Just take the two carbon atoms. So to take the two carbon atom and draw as it is. And between them, because it's a monomer and addition polymer, so addition polymer is formed by breaking down the double bond of a monomer. So there should be a carbon-carbon double bond. In this question, a condensation polymer can be made from the following monomer. These are the monomer. So two carboxylic groups are there. What we call that as a dicarbo. In short, I'm writing dicarbo. It means dicarboxylic acid. NH2 groups are there. It means diamine. So dicarboxylic and diamines. Which polymer they will form? This will be condensation polymer, but it will be nylon or polyester. So this will form a nylon. And how they form a nylon? One side for carboxylic, one side you will remove for carboxylic acid, you will remove OH both side, and for nylon, for amine group, you will remove hydrogen. So when I draw the structure, not two both hydrogen, you should remove only one hydrogen. So when we draw the structure, so OH is removed. This OC, actually, what is the meaning of this OC? It means C double bonded with O. Then there is CH2 bracket 4. Then this CO means C double bonded with O. NH2 means nitrogen means form a bond with two hydrogen, but one of the hydrogen is removed, and nitrogen and carbon will form a bond. So this will be CH2 bracket 6 and NH, put a bracket and then N. So this is of 3 marks, the structure of nylon. Is it clear? The formation of the nylon. That carboxylic will lose its OH and amine will lose its one of the H. These are the questions which I gave you as a homework. Synthetic polymers are disposed of in a landfill site and by burning. Landfill site means like dumping, like garbage is there, we just dump on the ground, that's called a landfill. And burning combustion is there. Describe two problems caused by disposal of synthetic polymer in landfill sites. So if we use a landfill site, like we are disposing of the polymer by just putting on the ground or using a landfill or a space for dumping this polymer. So what could be the dangers? So the dangers, it will be a shortage of the land, because what happened, like example, if you are dumping a garbage on the land, so this land size which is available for you will decrease. So the shortage of the site or the landfill site will fill up a time, and it will also produce a visual pollution, or litter will be there, too much garbage, and it can be danger to wildlife as well, because like the animals can also may be affected by eating or taking intake this polymer, as well as toxic chemical can leach into a soil and that can affect the soil as well. Describe one problem caused by burning of synthetic or man-made polymer. It produces toxic gases or greenhouse gases. State two uses of synthetic polymer, man-made polymer, where we use plastic bags, we use clothing, we use packaging, we use cups, even polystyrene cups are there. We use even carpets having these polymers, polyester, lot of greater proportion is there. Insulation, pipes. Draw the structure formula of monomer A. So how we draw the structure formula of monomer A? You can see this is addition polymer. So just take 2 carbon out and draw the structure. That will be a monomer. Identify the functional group circled in B. Which group is circled here? What is this group? So that is the ester group. And deduce 2 types of organic compound which have reacted in polymer B. How ester is formed? So which 2 type of compounds will react to form this ester? So ester is formed by alcohol and carboxylic acid. Like one should be alcohol, another one should be carboxylic acid. We will continue this discussion next session, means tomorrow, about this polymerization, addition and condensation. Any question or a doubt related to the class today?